Hello students, this is Yashobani. In this video, we know about the polygon clipping algorithms. Okay, let's start. Cohen-Sutherland line clipping algorithm we saw in our last video. In this video, we know about the how the polygon will be clipping. Before that, we know about the what is a polygon and what are the types of a polygon. So in this video, how the convex and concave polygon will be clipped to the viewport. Okay. So what is a polygon clipping? Or a polygon is a closed figure bounded by straight lines with a one bounded component and a one unbounded component. In computer graphics, both the convex and concave polygons are used, and how we have to clip the polygon's edges will be coming outside of the window. That will based on this. This video is based on that clipping or polygon clipping. Okay. So, it's a fundamental computer graphics technique to find and display only the visible parts of a polygon that fall inside a defined area. That is a clipping window, or we can say a viewport, right? Means what we have to, in last video or last class we saw the line clipping algorithm. So clipping is nothing but we are removing or cut the a given line in a parts. Means how much window is given, that much of a line will be visible, right? This is called a clipping. Means how the this line is displayed like the only the window port, the are clipping windows, right? So here where line is clipping with the this part, only the edges will be coming outside, those are have to clip. Okay, this is a clipping, lining clipping. Now what is a polygon clipping? A polygon clipping is the where the edges will be coming outside of the any given polygon. Okay, this is a polygon, right? So basically the line, this is a closed loop. The straight lines will be joining and make the a geometrical shape, you can say. Those are called a polygon. So this is a example here. This is window viewport, right? The polygon edges are coming outside. So how we have to clip this, and how the after the clipping, how the windows or a polygon will be looks, means it just clip the this line. Okay, so this is your clipped polygon. The edges will be intersecting, where the intersecting with the windows boundary, that much we are clip that. Okay, means how this output will be looks, it looks like this. Okay, means edges, outside the edges will be removed and remaining are the inside the polygon. Okay, this is how we have to make the polygon will be visible using the polygon clipping algorithm. And it is a systematic cutting off or clipping the polygon edges that extend outside the window. Alright, it extend the outside window, that edges will be removed, resulting in a new smaller polygon or a multiple polygons. How many polygons are there in a window, that much will be visible, that fits within the view, essential for rendering sense efficiently and accurately. So what are the algorithms are used here? How the polygons will be clipped? The polygon clipping algorithms are, first one is Sutherland Hodgeman and Wheeler-Atherton algorithm. These both algorithms are used to clip the polygon. So first in this video we are covering the Sutherland Hodgeman. Okay, how the polygons are represent, polygon clipping, the polygons are represent. It's representing a set of vertex as a P1, P2 up to Pn. Okay, then edges will be P of I, means how the what they saying, this is your polygon, right? So polygon is these points vertices are taken with the any alphabet of a P1, P2, what so until of P of n. Then what the edges is? Edge is from P1 to P2. Vertex to the joining the line. This is called a edge. Okay. So for this edge will be P of I of a P of I plus 1. Means for I is incrementing 1, 2 and n of minus 1. Okay. So P of n, P of 1 is also an edge. Okay. So this is a representative and this is a circular linked list we are representing. So the graphic outside predefined area is called a clipping. Means this is your polygon, this is your window. That means how the visibility of that polygon. This process will be cutting these edges is called a clipping, right? So clipping polygon algorithms takes one collection and outputs on a new collection. Okay. So given is this one and output we getting the clipped one. So that's called a new clipping algorithm, clipping windows. Okay. So in Sutherland Hodgeman repeatedly clip a polygon against each boundary edge. Means whatever the end windows is there, the polygon will be crossing that window. The edges will be repeatedly clipping that one. It's a maybe the window is given. Its edges will be started clipping with the left, right, top, bottom. It is a sequence left, right, top, bottom. But in Cohen Sutherland we can take any possibility. Means we can move on to the first right, then left, bottom, top, or you can take a left, right, top, bottom. Any possibility we can set take this. Okay, there is no fixed a sequence of clipping the polygon. Okay, so the procedure, the final visible shape is based on how we are clipping the edges of the a polygon to the respect to the window, left, right, top, bottom. Okay, so in basically we covering we taking the consideration of Sutherland Hodgeman polygon clipping. The steps: first we have to against a convex clipping window by processing it against each edge of a window. Means the given is the window and we have to take the polygon's edges. So read this all the edges. Next, sequentially we can take the left top, right bottom, or we can with the help we can take a right top, bottom, right, left. It works on any order. Okay, this is the second one. Using the output vertex means suppose we are moving to the left. So here we are to mentioning the vertex name A, B, C, D, or you can say P1, P2, P3, P4. So in this condition, we have to save the edges vertex as well as the edge value. So intersecting here P1 is outside the window. Then we take the intersection point as a P1 dash. So this intersection point will be stored in the output. Okay. So using the output vertex of one stage as an input for the next, progressively remove parts of the window outside the window. How many parts edges will be outside vertex are there. So we have to clip that. How we are clipping? The taking the intersection point of that particular vertex to the dash one. Okay. So it will store the values of a one stage output to the input for the next stage. Okay. So final clip polygon will be we got the clipped the polygon. Okay. There are four possible cases are there. First case, if the previous vertex is outside, means here previous vertex is outside means P1 is the starting one, P2 is the next one. So this one is outside, then that condition the current is inside the window boundary. means P1 is like this. This is P2. In next slide we have the images as well. So for just focus on the sentence I am taking. Means first case is if the vertex V1 is outside the boundary and V2 is inside, then what we have to save? The save will be a P dash value and a P1 dash. The intersection point will be stored as a output. Okay. So here this is P2 is inside. So P1, P2, P1 dash and P2 will be stored as a output. Second case is if the both vertex are inside the window, means P1, P2 or V1, V2 are both are inside, then we take the next value, that is V2 we can save in the output. Okay. Both we have to take the this one P1, V1, this is V2. The final value will be that is a current vertex, so save that one in the list. Next, third case, if the previous vertex is inside, okay, here the previous vertex is outside, but here the previous vertex is inside the window boundary and the current vertex is outside the window. Means here like this. Okay, this is your the previous is inside and current is outside, then the intersection point will be taken the consider and it will store in the list. Okay, or you can add it in the list. If the both vertices are outside, means this one, the both vertices is outside, then that condition there is no intersection between the window, right? So that's why we are neglecting, or you can store none in the table, or you can in the list. Okay, so we will not store any output in that case. That is a fourth case. So here the example, this is a given polygons with the edges. Okay, so left clip means this much will be clipped. Okay, so next this is right clip, and after the clipping one edge, we have to continue with the same thing and we are clipping the next one. Okay, after this we have to take this figure. Okay, next top, we have to remove the top. Next it's a bottom. So after the clipping, this is your given and this is your output. So clipping in a left, right, top, bottom. So while doing this, we have to maintain the vertex. Which vertex will be saved in as output of that particular edge, and it is input to the output for the this particular edge will be act as an input to the next vertex. Okay, so this is the first condition where the current is outside and previous is outside and current is inside. In that case we have to save the V dash and V2 as a output. In this both are inside, then we take the current as in our output list. So this is V1 is inside, V2 is outside. So V1 dash will be taken as the output. Okay, both are outside the window, then we have to store none. Okay, this is a figure with the help of figure. This is your given. First we have to clip in the right one. Okay, then top and left, and here we have to take a bottom. So after clipping this, we will get this output. So how we have to maintain the algorithm? Means here we are saving the edges value as a output as a input. Read the coordinates of a vertex. First step. Okay. Second step, consider an edge of the clip window and compare the vertex of each edge. Record the intersections. Okay. So step 3, store the new intersection and the vertex in the new list of a vertex. Fourth, in fourth step, we perform a step 2 and 3. Means we have to perform a right, left, top, bottom, right? So for that you have to repeat the step 2 and 3 for the remaining edges and clip the each time. So finally we have to get the output and finish this. Okay. In next video with the example we have to do a numerical of a given polygon clipping, that is a Sutherland Hodgeman clipping algorithm. Okay, we will see in the next video. Thank you.